As Java developers, we use the synchronize keyword for locking. The most popular view among developers is that we need the synchronize keyword because a thread needs exclusive access to a piece of code so that the object that we are changing does not go into an inconsistent state. Now that's a perfectly good reason for synchronization. But in this video, we will see yet another important reason why synchronization is necessary in Java. On the screen, you see a simple example of using the synchronize keyword for mutual exclusion. Let's say we have a class called IDGenerator, which is used to generate unique identifiers and which can be used by multiple threads in a JVM. By using the synchronize keyword here, we are using the class level lock for accessing the method. A thread will acquire this class level lock before proceeding to access the method. So in this example, all threads calling the getNextID method will have to wait for their turn to get into the method and get a unique ID. If the synchronization was not there, then two different threads can get the same ID, and this can be disastrous depending on the use case. This mutual exclusion point of view about synchronization is very true, but it tells only half the story. Let's look at the other half of the story. But before that, we will talk about two different concepts, atomicity and visibility. One thing as Java developers we should know is that the Java language specification guarantees that a variable assignment is always atomic unless it is of type long or double. What does atomic mean? It means that if a member variable in an object is set by one thread, then another thread will see either the changed value or the old value, but not an arbitrary value, not a random set of bits. Now this is true even if we are not using synchronization for accessing and updating the variable. Let's take an example of a bank account class as shown on the screen. Note here that we have not used synchronized in the getAmount or the setAmount methods. Let's say we have two threads who are accessing an object account, thread 1 and thread 2, and we assume that the object account is accessible to both thread 1 and thread 2. Let's say thread 1 sets the amount to 1000 from initial 0. If thread 2 calls getAmount at a later point of time, it will either see 0 or it will see 1000 and not anything else. It will never be a random bits. Now this is true, as I have mentioned before, whether the getter and setter are synchronized or not is not important. Now here you might think, because the update to amount variable is atomic, we do not require synchronization for the getter and setter methods. However, atomicity guarantees only that the threads do not see an arbitrary value. It does not guarantee that the change made by one thread is visible to another thread immediately. And here we come to the second most important reason for synchronization, visibility. That's the second half of the synchronization story. Synchronization is used not just for mutual exclusion, but also to make sure that each thread which enters a synchronized block sees the effects of all the previous changes done under the same lock, maybe by different threads. In other words, visibility of the changes made in one thread is also a very important reason for using the synchronized keyword. If we do not synchronize the getter and setter methods, the changes made may not be visible to other threads. So here on the screen, I have made the changes to the getter and setter methods for the variable amount. And note here that the synchronization is used solely for making the changes visible to other threads and not for mutual exclusion. And another piece of note is that not only the setter method, the getter method also needs to be synchronized. Now by doing this, if I go back one slide, account.getAmount, which is called by thread 2, is guaranteed to return 1000, assuming of course that the thread 1 has already set that amount before. Now there is yet another way to make the change visible without using synchronized. If we are making changes to a single variable and mutual exclusion is not required, then we can also use the volatile keyword on a member variable. If we use volatile, then we do not require the synchronized keyword anymore. So on the screen now, you see that we removed the synchronized keyword for the getter and setter methods because no mutual exclusion is required over here. We use volatile for the member variable. The volatile keyword guarantees that any thread reading the value will see the latest change. But be extremely careful when using volatile because volatile does not give us mutual exclusion. It does give us visibility, but no mutual exclusion. For example, if you look at our very first example of ID generation, you see that on the screen, we cannot simply add volatile to the next ID variable and remove synchronization. Why? Because the getNextID needs mutual exclusion to work well in a multi-threading environment. You see that next ID equal to next ID plus 1, that requires mutual exclusion lock. And that's why what you see on the screen is basically a bug. Now in certain cases, you may also think about using the inbuilt atomic classes, where we do not need to use synchronization. On the screen, you see an example of atomic long class being used, where the mutual exclusion is confined to a single variable, which is the next ID. Here, the mutual exclusion logic is handled by the atomic long object, and we don't have to explicitly synchronize the method. Note here that even though the next ID variable is made final, it simply means that the next ID field cannot be updated. However, the object itself can be modified by calling one of its updater methods. So in summary, the synchronize keyword has several purposes. Not only is it used for mutual exclusion, but also for making the changes visible to other threads. In fact, it takes care of mutual exclusion, atomicity for long and double. Remember, those are not automatic, and visibility to other threads, all of them at the same time.